Our sense of touch feels so real, so immediate. We reach out, our fingers brush against an object, and we feel the smooth surface of a table or the rough bark of a tree. But what if I told you it's all in your imagination? We never truly touch anything at all. Our reality on the atomic level is far stranger than it appears. To understand why, we need to journey into the bizarre world of atoms, the fundamental building blocks of everything we see and feel. Atoms are incredibly small. Imagine a single grain of sand. Now imagine dividing that grain of sand into billions of tiny pieces. Each one of those pieces is roughly the size of an atom. But here's the even more mind-boggling part. Atoms are mostly empty space. The nucleus is incredibly small compared to the atom. Imagine stretching an atom to the size of a hall. The nucleus would be even smaller than a mote of dust. An atom is made up of 99.9% empty space. At the center of every atom lies a nucleus, a dense core made up of even smaller particles called protons and neutrons. Whizzing around this nucleus, like planets orbiting a distant sun, are electrons. These electrons are constantly in motion, forming a hazy cloud around the atom's core. They have the power to prevent you from ever touching anything. Electrons carry a negative electrical charge. Just like two magnets with the same poles facing each other will repel, electrons push each other away. This fundamental force of nature is what prevents atoms from ever truly touching. When your finger comes close to a surface, it's actually the electron clouds of the atoms in your finger repelling the electron clouds of the atoms in that surface. This creates a tiny, invisible barrier between your skin and the object. This force is incredibly strong relative to the size of an atom. And that barrier? That barrier is preventing you from touching anything. The field force at the atomic level will repel any other atomic structure you try to touch. Now you might think, if atoms never actually touch, how do I experience the sensation of touch? This question delves into the fascinating world of atomic interactions and the forces that govern them. The answer lies in the intricate interplay of forces between atoms and how our bodies interpret these interactions. It's a delicate balance of attraction and repulsion that creates the physical sensations we feel every day. Material objects never truly touch due to the force of the electron clouds. Every time you push an object, it's actually your electron clouds pushing against the other object's electron clouds. You can never truly make physical contact with that object. But hey, look on the bright side, that's as close as you can get to achieving that dream of superpowers. When you press your hand against a table, the electron clouds of the atoms in your hand and the table repel each other. This repulsion prevents the atoms from actually touching, but at the same time, the electrons in your hand are slightly attracted to the protons in the table's atoms, and vice versa. This subtle attraction adds another layer to the interaction. This complex dance of attraction and repulsion sends signals through your nervous system to your brain, which interprets these signals as the sensation of touch. It's a remarkable process that allows us to interact with the world around us, making the intangible tangible. Every time you touch something, whether it's the smooth surface of a table or the rough texture of a rock, this atomic dance is at play, creating a unique sensory experience. We feel pressure, texture, and temperature, not because we are physically merging with the objects around us, but because our brains are wired to translate these atomic interactions into meaningful sensations. The world we experience through touch is, in a sense, a construct of our brains. So will I never touch anything in my life? Well, don't be sad. You better hope you won't. It's not impossible for atoms to actually touch each other. All it takes are extreme forces and it becomes possible. There are places in our universe where atoms actually touch. But to get your atoms to touch other objects' atoms, your body will melt or tear apart for you to actually touch something else, or what left of you in this case. In the cores of stars, where temperatures and pressures are immense, atoms can be forced closer together than they would be under normal circumstances. These conditions are so intense that they push atoms to their limits. This can lead to nuclear fusion, the process that powers the sun, where atomic nuclei overcome their natural repulsion and fuse together, releasing enormous amounts of energy. This energy is what makes the sun shine so brightly and provides the heat and light. In these extreme environments, atoms do touch, or at least get close enough for their nuclei to interact directly. Nucleosynthesis within stars and supernovae is a cataclysmic event that underpins the very existence of stars and the creation of elements. These processes in the hearts of stars are responsible for forging the elements that make up everything we see around us, from the oxygen we breathe to the iron in our blood. In the normal, everyday world, atoms are held at a specific distance from each other due to the balance of attractive and repulsive forces. These forces are like a cosmic dance, ensuring that atoms maintain a respectful distance from one another. This balance is what gives objects their solidity and prevents them from collapsing in on themselves. It's the reason why a table feels solid when you press your hand against it, even though it's mostly empty space at the atomic level. So let's just be happy with our senses of the repelling forces. The next time you reach out to touch something, the feeling of your hand on a surface, the warmth of the sun on your skin, the coolness of a breeze, these are all manifestations of the fundamental forces that govern the universe, translated into sensations we can feel and understand. Each touch, each sensation. Though we may never truly touch anything in the strictest sense, our sensory experiences are no less real or meaningful. The electromagnetic forces at play create a barrier, a cushion of sorts that prevents actual contact, yet allows us to feel the presence of objects and surfaces. They connect us to the world around us and allow us to perceive the beauty and complexity of a universe built on emptiness and the invisible forces that hold it all together. While at the atomic level we may not physically touch anything, it doesn't alter our sense of touch. In reality, we wouldn't want to touch anything at the atomic level. So don't worry, your sense of touch isn't going anywhere. However, your sight is a different story. There are beautiful phenomena that we will no longer be able to experience. You will never be able to gaze at the Milky Way in our night sky again. In the coming decades, stars in the skies will become a rare sight. Watch the next video to find out why.